Okay, so we're going to write an equation of a line that passes the point 4, -4, and is perpendicular to the line y equals -2/3 x minus 6. Want to focus on this -2/3 because that's the slope. Perpendicular means flip and reverse or opposite reciprocal, and it's going to the point 4, -4. So label our point x1, y1, and perpendicular means opposite reciprocal, or Miss Moreno likes to say flip and reverse, right? So I'm taking this -2/3, and I'm going to flip it. And when I do that, it's going to give me a -3/2. And then I'm going to reverse it. It's going to be negative. Now it's going to be positive 3/2. And there's my new slope, positive 3/2. Now that should right away get rid of all of your other options and give you your only option choice, which is 3/2 x minus 10. But let's just go ahead and keep going just in case, right? Okay, so I know my new slope. My new slope is a positive 3/2. Okay, and if I label x1, y1, I can use my point slope formula. Y minus y1 equals m times x minus x1. Okay, you can put all your new pieces together. Y minus y1, so y minus -4 equals m, which is 3/2, times x minus 4. Okay, work your way through, distribute your 3/2. You're going to get y plus 4. Y plus 4, because it's a change. So that's y plus 4 equals 3/2 times x, which is 3/2 x, minus, right? So 3 times 4 is 12. 12 divided by 2 is 6. So that's minus 6. So we have y plus 4 equals 3/2 x minus 6. Subtract 4 to both sides, and you're going to get y equals 3/2 x minus 10, just in case. Okay? So that's our answer choice for number 1. Okay? And that's another way to kind of look at your answer choices and see if you're correct. All right, number 2, same thing, except this time it's parallel. Parallel is the easier of the two because parallel means same slope. Since my slope is 3, I know that I'm looking for 3, but notice your equations, they're in standard form, okay? x1, y1. Let's keep working, okay? So we're going to use a slope, m equals 3, because that's what parallel means. It means same slope. Notice perpendicular, we had a new slope. So parallel means same. So we're going to use that same formula. Y minus y1 equals m times x minus x1. And you guys can find these formulas on your formula chart inside the resource folder, okay? So go ahead and plug this in. We have y minus -7 equals 3 times x minus -6. Don't forget to do your change, right? That's actually y plus 7. That's actually x plus 6. Okay? If I distribute my 3, I'm going to get 3x plus 18. Okay? Y plus 7 equals 3x plus 18. Subtract 7 to both sides, and I get y equals 3x plus 11. Now, unfortunately, none of these lines are in that form. So what I have to do is I have to move this 3x over so that I can get it in standard form, right? Where the constant's by itself. So in order to do that, I subtract 3x to both sides. And if I subtract 3x to both sides, I get the equation -3x plus y equals 11. Okay? And notice I'm getting a constant by itself when we're in standard form. Okay? Number 3. Okay. In the diagram below, the measure of angle 8 right here is 50 degrees. Find the measure of angle 2 so that line A and B are parallel. Okay, so I'm going to give you guys a little bit of a hint. First of all, 8 and 2 don't really have any relationship whatsoever. But when we're looking at this is the parallel line, right? That means that A is parallel to line B, right? The biggest thing that I want you guys to take away from are acute angles, right? So look at your page, look at your picture. All acute angles are congruent. All obtuse angles are congruent. That's the big thing I want you to take away. Acute angles are congruent. Obtuse angles are congruent. So let's look at angle 8. Angle 8 looks like it's an acute. Well, it's 50 degrees, right? So that means it's acute. Angle 2 looks like obtuse, right? So those two, they're not congruent. So we know it's not 50. Okay, so what other angle measure could be? Well, guess what? Whenever you have an acute angle and an obtuse angle, and the lines are parallel, and this is only for lines that are parallel, okay? They're supplementary. That means they add up to 180. So if that angle is 50 degrees, and that's an acute angle, then an obtuse angle must be 130. Now, I want you to make sure this is the way you really should see it. Angle 8 and angle 4 are corresponding angles. They're congruent, right? Because the lines are parallel. So that means that this is 50. We know that these two angles form a linear pair. Since that angle is 50 degrees, that means angle 2 and 4 add up to 180. 50 plus angle 2 equals 180, right? Subtract 50 to both sides, and you get angle 2 equals 130. Okay? So that's the one thing that I do want to take away. Make sure that you understand acute and obtuse angles here. Okay? All right, number 4. Now it's looking at the saying that these lines are all parallel. So basically, BC is parallel to AD and AB is parallel to CD. We're trying to find the angle of CDB. So here's CDB. So this is the angle we're looking for right here. We'll call this angle X. That's the angle we're looking for. Again, these lines are parallel to each other. So when these lines are parallel to each other, that means that my obtuse angles and my acute angles are supplementary. So that means that this 120 plus this angle right here should be equal to 180 degrees. All right. So we take the 120 plus 15 plus x, because this is our unknown, and that should equal 180. If I combine these two right here, that gives me 135 plus x equals 80. Subtract 135 to both sides, and I get x equals 45. Okay. Now, make sure that you're looking at the labeling and the angle, right? CDB. So here's CDB. That's why we're using this angle X. If I plug that in, 45, 45 plus 15 is 60, 60 plus 120 is 180. Okay, these lines are parallel. It doesn't matter what the picture looks like. It matters on what's going on with this wording, okay? All right, so here we go. And number 5 says point C is 3, 3, 5 and is contained on a line that is parallel to the line y equals 2x. Which of the following equations best represents line M? Well, the key word here is parallel, right? Parallel means same slope, so that means my slope's going to be 2, right? So guess what? That one's definitely out. This one's possible, but this one would be the same line. This one's possible because it would be the same line. And we're not 100% sure here, okay? But let's look at the point. The point's 3, 5. That's x1, that's y1, okay? All right, so we're looking for the slope. Parallel means same slope, so we know that our m is going to be 2, okay? And our points x1, y1. So we could put our formula, y minus y1 equals m times x minus x1, right? So y minus 5 equals 2 times x minus 3, okay? And we notice it right there. These two are exactly the same. So that would be your answer choice for number 5. Okay. If you wanted to, you can keep on going on to check and see if this is correct. See if it's the same line, right? Distribute. You're going to get 2x minus 6, y minus 5 equals 2x minus 6 plus 5 plus 5. You're going to get the line y equals 2x minus 1, which is not up there, right? Okay. All right. So let's go on to number 6. Set parallel lines. That's what it means. That's what these double bar means. X is parallel to Y. The measure of angle 1, so this angle right here, is equal to 55 degrees. Determine the measure of angle 5. Again, the lines are parallel. Those two angles are acute angles, right? So they're congruent. But they're also what we call corresponding angles. When lines are parallel, corresponding angles are congruent. So that means that the measure of angle 5 is also 55 degrees. Number 7, again, we're dealing with the same set of lines. X and Y are parallel. The measure of angle 4 is 5x. So this angle is 5x minus 10. Okay. And the measure of angle 6 is 10x plus 10. determine the value of x. Well, again, we have an obtuse angle and an acute angle right here. And the lines are parallel. They're not the same because one's obtuse, one's acute. That means that they're supplementary. They add up to 180. So we say that angle 4 plus angle 6 equals 180. And we substitute these expressions in for those two angles. So we're going to say 5x minus 10, because that's angle 4, plus 10x plus 10, because that's angle 6, equals 180 degrees. All right, now we start solving for x. Combining my like terms, minus 10 plus 10. Guess what? Those cancel. 5x and plus 10x, that gives me 15x. 15x equals 180. Divide both sides by 15. And I believe x is, what is this? 180 divided by 15. Let's use my calculator, right? 180 divided by 15. 12. Woohoo! All right. So my answer choice is 12. And there we have it, right? Awesome. That's the value of x. That's not the measure of the angle, just in case, right? X is 12. All right, number 8. Okay, it says given x is parallel to y and the measure angle 2 is 132 degrees, the measure of angle 7 is equal to 5x plus 2 degrees. What is the correct setup for x and y? Well, let's look at angle 2 and 7. Okay, these lines are parallel, right? 2 and 7 are alternate exterior angles, and if you look at them, they're obtuse. Both of them are obtuse. So that means they're congruent, right? So we set them equal to each other because they're alternate interior angles, and alternate exterior angles are congruent. So we set them equal. So this one's gone because we're adding to 180. This one's gone because we're adding to 180. These two are possible. Let's see. Let's read it. Because the angles are alternate exterior angles, and alternate exterior angles are congruent when lines are parallel and cut by transversal. That looks good. Because the angles are corresponding angles, and corresponding angles are congruent when lines are parallel, cut by a transversal. See, this is where we got to understand. These two statements are true, but based on the picture, 2 and 7 are not corresponding. They're alternate exterior, so this should be the right setup. Okay? All right, number 9. Basically, we're just solving for x. Now, we know the setup, right? We know they're congruent based on the last question that we just said. So 132 equals 5x plus 2. Subtract 2 to both sides. Okay, we get 130 is equal to 5x. Divide both sides by 5. Okay, 130 divided by 5, I believe is what? 26. 26. Yep, 26. All right. All righty. Number 10. Okay. We're assuming that Q and R are parallel. Click all that apply for the angle relationship and properties of angles 2 and angles 4. They're both obtuse. The lines are parallel, so we know they're congruent, right? Okay. Angles are congruent. That's one thing we definitely know. Now, what are angles 2 and angles 4? Well, they're on the same side, so they're not alternate. One's on the outside, one's on the inside, so they're not consecutive. So that must mean they're corresponding because they're in the same position. Look at your intersection right here, top right, intersection, top right. Okay, that's what corresponding angles are. Okay, so that's right there. Let's go to number 11. Okay, it says the measure angle 7 is 12x minus 8. The measure angle 3 is 5x plus 6. Look at these two angles. They're both acute. That means they're congruent. They're alternate interior angles. Alternate interior angles are congruent. So what does that tell me? That tells me that 12x minus 8 is equal to 5x plus 6 because the definition of congruency means equality. Okay, now I can set this up. I'm solving for x because the lines are parallel. That's the most important part. Subtract 5x to both sides. You get 7x minus 8 equals 6. Add 8 to both sides, and you're going to get 7x equals 14. Divide both sides by 7. X equals 2. Ta-da! All right. Almost done, guys. Question 12. Okay, let there be coordinates D, F, E, and G, right? And we can see the point values, which describes the relationship between the slope. So we're talking about slope here, right? Slope of DF and EG. So let's look at DF. DF, negative 4, 3, 2, 7. So label your points, as always, x1, y1, x2, y2. And we're going to use our slope formula, which is m equals y2 minus y1 over x2 minus x1, right? And if they're the same, they're parallel. If they're flipped and reversed, they're perpendicular. If they're not the same and they're not perpendicular, then there's no relationship. And if it's the same line, they have the same y-intercept, okay? So let's look at D and F. So we're going to find the slope, right? Do your little setup and then start plugging in your values. Okay, so y2 was, what is it, 7, right? So 7 minus 3 over 2 minus negative 4, right? 7 minus 3 over 2 minus negative 4. Okay, 7 minus 3 is 4. 2 minus negative 2, that's got to be change, 2 plus 4, so that's actually 6. 4, 6, don't forget to reduce. That's 2/3. So the slope of DF is equal to 2/3. That's my slope. Okay, I'm going to go ahead and clear all this business. Oops. Because we know our slope's 2/3, right? All right. Now, let's find the slope of the other line, right? And we got to label our points, x1, y1 for this new slope, x2, y2. So now we're going to find EG. Okay. And EG, we label, we do our slope formula, m equals divide minus minus, set it up. Now we plug in our values. Okay, y2 is 9, minus y1 is 6. Okay, x2 is negative 5, minus x1, which is negative 4. Okay, 9 minus 6 is 3. Negative 5 minus negative 4, that's a change, right? Negative 5 plus 4 is 1. Okay, that's 3 over 1, that's slope of 3. Those two slopes are not the same. They're not perpendicular. That means they have no relationship whatsoever. Okay, all right. Next one. Same exact setup, except now, we're just, we got to use the slope formula, right? M equals y2 minus y1 over x2 minus, x2 minus x1. Okay. Again, pretty much same question, just new coordinates. Here's one set of points. Here's two set of points. Okay. It's describing the relationship based on those two lines, DF. So let's go ahead, label your points, right? x1, y1, x2, y2. Let's find the slope of DF. M equals minus minus. Let's set them up, right? Okay, x1, y1, x2, y2. And it just doesn't look good with mine. Okay, so we know y2 is 2. So 2 minus 6 over 4 minus 2. 2 minus 6 over 4 minus 2. 2 minus 6 is a negative 4. 4 minus 2 is 2. Negative 4 over 2 equals negative 2. So my new slope for, or not my new slope, my slope for DF is negative 2. All right. Okay. Now let's find the slope of EG. Okay. So here we have EG. Again, we're going to do the same formula. M equals divide. Label your points. x1, y1, x2, y2. We have 7 minus 8 over negative 6 minus negative 4. 7 minus 8 is negative 1. We have to do a change here because we're subtracting a negative. Negative 6 plus 4 is negative 2. Negative 1 over negative 2 gives me a positive 1 over 2. So the slope of EG is 1 over 2. They're not the same, so they're not parallel or the same line. So we need to tell whether they're perpendicular or no relationship, right? So we take -2, let's flip it, right? Flip -2, we get -1/2, right? Let's reverse it. Guess what? We get +1/2. So that means these two lines are in fact perpendicular to each other. Okay. Two more. Number 14. Okay. Corresponding angles conjecture states that if two parallel lines are cut by a transversal, so two parallel lines cut by a transversal, the corresponding angles are congruent. This picture below shows this relationship. Which of these angle pairs are corresponding angles? So angle 1 and 4. They're not corresponding angles because they're not on the same side and in the same position. Angles 1 and 3? Nope. Angles 5 and 6? Nope. Angles 3 and 7. These two angles are in fact on the same side and they're in the same position. If this is my intersection, this is on the bottom. This is my intersection, it's on the bottom. So that's what it means to be corresponding. Same side, same position. All right, number 15, last question. Which of the following facts proves that line A is parallel to line B? Okay, it's not saying which of the following facts is true. It's saying which of the following facts proves that line A is parallel to line B. Now, why do I say this? Let's look at angle 5 and angle 4. Okay, well, obviously those two aren't congruent, right? Because those are consecutive interior. But let's look at this angle 2 and angle 7. Those are alternate exterior, possible. Angle 5 and 2. But look, angle 5 and 2, those are congruent. That's a true statement. But just because this is a true statement, that's not going to tell me anything about line A and B being parallel. Okay. Same thing with 7 and 3. 7 and 3 are congruent because they're vertical angles, but that doesn't tell me anything about line A and B being parallel. So these three statements are all true, but this is the only statement 2 is congruent to 7 that will tell me that these two lines are parallel because it's talking about the two lines that are being cut by a transversal. Notice 5 and 2 is just talking about A. 7 and 3 is just talking about B. Angles 2 and 7 is talking about an angle on A and an angle on B. Okay, and that's it, guys. Hopefully you guys have a good time on the review. You understand everything. Go back and look at anything that you might need. Have a good day.